Good morning, ladies. It's Mr. O'Sullivan. Today we're going to be looking at Lesson 4-3, Multiplying Monomials, an Introduction to the Area Model. So we've been hearing these weird terms over the past few days. Monomial, binomial, trinomial, polynomial, quadrinomial. We've been learning all these terms. But here's the thing, we're in algebra, so we want to actually perform operations on these terms. So what we're going to be doing today is we're going to be looking at how to multiply two monomials by using the area model. Well, when we multiply monomials, we're not necessarily going to use the area model, but when we multiply a monomial by a binomial or a trinomial or whatever, we will be using the area model, which we'll be going over very shortly, so don't worry. So today's learning target is I can apply my knowledge of the area model by multiplying two monomials or a monomial by a binomial. So remember, a monomial is very special. It's just one term. So for instance, 5x is a monomial, negative 5x squared is a monomial. I could also say the number 3 is a monomial. A binomial is two terms that are separated by addition or subtraction. So I can say 3x plus 5 is a binomial. I can also say 5x squared minus 9x is a binomial. And those are the things we're going to be looking at today. So over the past few years, you've learned a variety of things about exponent rules. You learned about them in middle school. You learned about them. You really did learn a lot about them in middle school. So what we're going to be doing today is we're going to learn how to extend those rules to Algebra 1 by multiplying monomial expressions. But there are a few things that we need to be very cautious of. So let's look at this following example. So the steps for every monomial times monomial problem is the exact same. Step 1, you multiply your coefficients. Remember, the coefficients are the numbers attached to your variables. They're not the exponent, they're the numbers in front of our variables. So they're sort of like our base. So we're going to use exponent rules to simplify this expression, 3ab to the third power times 5a squared b to the fourth. So step 1 says multiply your coefficients. So what we're going to do is we're going to multiply our coefficients. And in this case, our coefficients are 3 and a 5. 3 times 5 is 15. Now it says step 2, match up your exponents and then add them together. So if I look, I have ab to the third and a squared b to the fourth. I really only have one a right here because I have a to the first. So whenever you don't see an exponent, it's really just an imaginary 1. And what we're going to do is we're going to line up our a's together. So I'm going to highlight my a's. And you just do 1 plus 2. 1 plus 2 is 3. So I get a to the third. Now I'm going to erase my highlight. And now we're going to multiply b to the third and b to the fourth. Well, again, you are adding your exponents. So 3 plus 4 is 7. And I'm doing it on my b, so it's b to the 7th. And that's my final answer. 15a to the third, b to the 7th. And that's step 3. Put it all together, and that's your final answer. So again, the procedure is multiply your coefficients, add your exponents. So for each of these examples, we want to simplify them. So what we're going to do is we're going to do the first few together, and you should pause the video to do some by yourself. So in this example, I have 5x to the third times 2x squared. Well, the thing is, I just multiply my coefficients. My coefficients are a 5 and a 2. We know 5 times 2 is 10. And I just look at my x's. What's 3 plus 2? It's 5. So my final answer is 10x to the 5th. This example here, negative 3x times a negative 8x. Here's one thing I want you to do. Every time you just have an x or a y or whatever variable, I want you to put a 1 in its exponent. So I have to ask myself, what's negative 3 times negative 8? Well, a negative and a negative make a positive. So negative 3 times negative 8 is a positive 24. And then I have my base of x. And I just do 1 plus 1, which is 2. So my final answer is 24x squared. Now we're going to be doing 1/2 x squared y to the 5th times 3 over 4 x to the 9th times y. So again, line up your coefficients. Line up your coefficients. Multiply them. 1 times 3 is 3. 2 times 4 is 8. So 1/2 times 3/4. is 3 over 8. Now I look at my x's. What's 2 plus 9? 11. Look at your y's. Ooh, there's a 1 here. What's 5 plus 1? 6. So my final answer is 3 over 8 x to the 11th, y to the 6th. You should try to do the next few by yourself, but if you're still stuck, pay attention. Here I have y times y. This is a pretty quick one. Put your ones up top. There are no coefficients for you to multiply, so my final answer will just have a y. And what's 1 plus 1? 2. Y squared is my final answer. Here, if you look at this example, there is no multiplication symbol. But whenever you have two parentheses, that's a sign that you're just going to multiply them together. So before we move any further, I'm going to put my ones with my x's. I'm going to multiply my coefficients. What's 4 times 2? 8. 1 plus 1, 2, so I get 8x squared. 2 plus 3, 5, so I get y to the 5th. So my final answer is 8x squared, y to the 5th. Now, let's go on to the area model. So the area model is something that you most likely saw in maybe elementary school. The area model is very, very important because not only does it pop up in Algebra 1, it pops up in Algebra 2 when you learn how to actually divide polynomials. So we're going to use the area model extensively in this unit to show you the intricacies of our expressions. So the area model. When you first start to learn how to multiply two-digit integers, there's a good chance that you use the area model. We're going to call it something special tomorrow, so if you're like, area model seems intimidating, we're going to show you something a little different. We're going to extend this to multiplying a binomial by a monomial. So remember, binomials are two-termed expressions, and we're going to be multiplying them by a one-term expression, or a monomial. You can also multiply a trinomial by a monomial. You can also do a binomial times a binomial. That's what we're going to be doing tomorrow. So the steps. Well, here's our problem. Simplify the following by using the area model. 2x times 3x minus 1. The first thing you're going to do is you're going to draw a rectangle with lines drawn in. Make sure that you have enough space on the top for your binomial and enough space on the left for your monomial. So what we're going to do is we're just going to draw a quick rectangle or a quick box. And it said make sure there's enough space on top for your binomial. So what we do is we have two terms, so we're going to have two separate boxes. So I'm going to put my 3x here and my minus 1 here. On the left, I'm going to put my monomial, which is a 2x. Now, go ahead and multiply. Make sure you multiply the coefficients and add your exponents for your like bases. So if I look, I have a 2 and a 3. 2 times 3 is 6. I have a 1 and a 1. 1 plus 1 is 2, so I have x squared. So what I'm doing here is I'm really just doing 2x times 3x. Now what I want to do is 2x times a negative 1. Well, 1 times anything is the number itself or the term itself, because we're learning about terms, and a positive and a negative make a negative, so this is just going to be a negative 2x. So my final answer would just be 6x squared minus 2x. Here's the thing, you don't necessarily have to use the area model. You could have just done distribution. So I'm going to show you that quickly. So I have 2x times 3x minus 1. You can use the area model or distribution for monomial by binomial or trinomial, or whatever the heck you want to call them. But tomorrow you're really going to want to use the box method. I mean the area model, sorry. So I have 2x times 3x, which is 6x squared, and then 2x times a negative 1, which is a negative 2x. So here I'm just using distribution, and here I'm using the area model. So let's simplify each of the following by using the area model. Note, your area models have already been drawn in for you. So simplify each of the following. So in this first example, I want to do 5x times 3xy plus 2. Well, if I look, this is really a 5x to the first and a 3x to the first times y to the first. So I'm going to do 5 times 3, because those are my coefficients, and get 15. X to the first times x to the first is x squared, because 1 plus 1 is 2. And then there's no y here, so I'm just going to rewrite my y. So I'm just going to have 15x squared y. Now what we're going to do is we are going to do 5x to the first times 2. 5x to the first times 2 is actually very straightforward. You multiply your coefficients, so my 5 and my 2, and I get a 10. And now I'm just going to rewrite my x. So I get 10x. So my final answer is 15x squared y plus 10x. And that's your final answer. Let's go on to our next example where we perform the operation of x squared times 4x squared plus 3. So there's no coefficient to multiply, so I just get my 4, because this is really a 1, so 1 times 4 is 4. X squared times x squared, I just add my exponents. 2 plus 2 is 4, so I get 4x to the 4th. And then when I do 3 times x squared, or 1x squared times 3, I just get 3x squared. And it's all positive, so my final answer is 4x to the 4th plus 3x squared. And that's your final answer. Let's go into our final example, which looks a little trickier because there's some negatives thrown in there. So in this example, I'm doing negative 2x squared y to the 3rd times 2xy minus 5x. I see in my 2xy minus 5x that there's no exponent. So what I'm going to do is I'm going to put a 1 in for each of them. So a 2x to the 1st and a y to the 1st and a negative 5x to the 1st. Remember, it's not negative 5 to the 1st. It's your variable to the 1st. So it's being x raised to the 1st power. So again, I multiply my coefficients. So I'm going to do negative 2 times 2, which is negative 4. I'm going to do 2 plus 1 because my x squared and x to the 1st line up. So I'm going to get negative 4x to the 3rd. And then I have y to the 3rd times y to the 1st. Well, 3 plus 1 is 4, so I'm going to get y to the 4th. And then last but not least, I do negative 5x to the 1st times negative 2x squared y cubed. Negative 2 times negative 5 is 10. X squared times x to the 1st is x to the 3rd because 2 plus 1 is 3. And then there is no y here, so I'm just going to rewrite my y cubed. So my final answer is negative 4x to the 3rd, y to the 4th, plus 10x cubed, y to the cubed. And a lot of you might say, Mr. O'Sullivan, why aren't you combining those? Well, if you look, they're not like terms. In this expression, I have a y to the 4th, and in this expression, I have y to the 3rd. The minute I have two different exponents, I can't combine them. If they were y to the 3rd, y to the 3rd, x to the 3rd, x to the 3rd, I would be able to combine them. I would get positive 6x cubed, y cubed. So that's it for today. You do have a Delta Math assignment, so please, please, please make sure that's completed. And if you have any questions, make sure you email myself, Miss Townsend, or Miss Jimenez. Have a great day, ladies.